我们邀请到的分享嘉宾呢是以太坊创始人、万向区块链实验室首席科学家 Vitalik， 协议实验室创始人 Juan Bennett，Dfinity 创始人首席科学家 Dominic Williams。
Next, I'm going to ask some questions around technology. I would like to start with Vitalik. We heard your keynote this morning. And from what we hear in the community, there has been a lot of discussions and expectation actually around Ethereum 2.0, discussions around scalability and state size, etc. And you talk about layer 2 solutions like rollups this morning. And earlier this year, you talk about 2 state size solutions. So my question is, could you talk a little bit about where we are now in the transition from Ethereum 1.0 to Ethereum 2.0?
Sure. So I think we don't really use the term Ethereum 2.0 as much anymore because I think when we came up with the term, there was an expectation that it would be a much more like drastic change from like one version of the blockchain to another. And I think the way that the roadmap works now is much more incremental, right? There are a few different changes, and each change only changes one or a few things. But from the point of view of an application, like not much changes, right? So because from the point of view of an application, like applications do not have to do anything to migrate from proof of work Ethereum to proof of stake Ethereum. Ethereum just becomes proof of stake, including all of the applications that are on it. So instead, like what we think of it as a series of separate upgrades. So I think the big ones are, one is the switch to proof of stake. And there are 2 phases in the switch to proof of stake. There was the launch of the proof of stake beacon chain, which happened at the end of last year. So now the proof of stake beacon chain has been running stably for almost 11 months. There's going to be the first hard fork of the beacon chain, Altair, later this week. And the second phase is the merge, right? And the merge is when the existing Ethereum system and all the applications on it get moved over away from the proof of work chain onto the proof of stake chain. This is an automatic process. It's just like a different type of hard fork. It happens automatically. So that's the end goal. Right now, we actually have had a lot of progress on the merge over the last month. We had a workshop where all of the core developers and researchers came together, and we managed to create public test networks for the merge, and we'll continue to have more test networks for it over the next couple of months. So a lot of progress there. And then the other big piece of what was called 2.0 is sharding. And I think the scaling roadmap now is basically that first we have these independent sort of community created rollup projects, and rollups can give the first boost of scalability. So a factor of 10 for simple rollups, maybe 100 for the rollups with more advanced data compression. And then later, we had data sharding for the Ethereum blockchain, which might come 1 to 2 years from now, and that will increase scalability first. So that's still in earlier stages, but there's a team working on it.
Thank you, Vitalik. Next, I'm going to ask Dominic. We know Dfinity is building an internet computer, and there has been multiple iterations after the mainnet launch. So could you elaborate a bit on how this supercomputer is different from the Web 2 computer as we know, and what could be challenging from a tech perspective?
Well, yeah, okay. So first of all, the internet computer is a blockchain, and you build systems and services on a blockchain using smart contracts. And smart contracts are a profoundly new kind of software that has amazing advantages. So of course, we all know that smart contracts run on a public network rather than on centralized cloud infrastructures like Amazon Web Services, and that's one big advantage. They're tamper-proof, you don't need to protect them with firewalls. They're unstoppable like the internet. They're both software and systems at the same time. They lie somewhere between, and you can compose them, which means you can build systems and services by composing sort of system units in the same way that you build software. Smart contracts can run autonomously, so you can use tokenization to create microeconomies and decentralized value. So we believe that because of the innate advantages of smart contracts, that a blockchain singularity will occur where nearly all of humanity's information systems and services will be rebuilt using smart contracts and run entirely from the blockchain. So for us, when we designed the internet computer, it was important to rethink existing blockchain architectures so that blockchain could act as the entire stack. So one of the interesting differences between the internet computer and traditional blockchains is that smart contracts on the internet computer can actually serve interactive web content directly to end users. So with some clever cryptography, end users can essentially interact directly with the smart contracts, which removes the need to use corporate cloud services like Amazon Web Services in the creation of dApps. And you can get total decentralization and true censorship resistance, which provides ways, for example, to apply more advanced tokenization strategies than you can currently employ in these more centralized architectures that you see today. So, we think that blockchain is the new internet, and the internet computer is designed to enable true Web 3.0, in which systems and services are built on blockchain using smart contracts. They have access to unlimited computational capacity, and they can serve interactive web content directly to end users, so there are no intermediaries. And in a few months, various decentralized economic rails will activate on the internet computer, and we'll see some very interesting things happening, I think.
Thank you, Dominic. So as we understand, the internet computer is built for Web3 users. Now I would like to move to Juan. We know Protocol Labs and IPFS ecosystem is the leader in distributed storage. You have attracted a large community of developers and users, but there are still some kind of entry barriers, like say equipment requirements, storage cost. So how do you think we can reduce the barriers and onboard more developers and users?
No, there's actually no cost barrier at all now with Filecoin Plus, which went live earlier this year. You can get storage orders of magnitude cheaper than the current cloud. So this is the world's cheapest storage service, and you can even get it completely free in some cases. So some users, depending on sort of where they are and which service providers they choose, you can get completely free storage for petabytes of scale. So I think at this point, the only barrier is people knowing about it. There's still a lot of hurdles in terms of onboarding tools, and you have to learn how to use the tech and so on. And so that's getting easier, but the barrier is really hearing about it and knowing that you can do it. Right now, there's about 200 or so petabytes of storage on the process of onboarding onto the network. And so really it's more people finding out about it, knowing that they should come, and then trying it out and starting to use it. So, in like the last 6 months, NFT storage, which is kind of like a developer onboarding tool for NFTs, is now storing most of the NFTs in the blockchain space is about over 6 million NFTs and about 40 terabytes of NFTs, and like that's just bounded by users wanting to use them.
Talking about NFTs, I think we are moving to the next stage of questions about applications. As we all see over the past year or so, DeFi and NFT have experienced tremendous growth across multiple chains. So what are your guys' take on the booming of DeFi and NFT? Are these applications heading in the right direction? And what advice would you give to teams in DeFi and NFT? Shall we start with Juan and then Dominic?
Yeah, I think